Hello everyone. I would like to present my project called Smart Signal Adaptive Traffic Signal Optimization System. First, I would like to explain why I choose this topic. Traffic congestion remains one of the biggest transportation problems around the world. Although roads continue to expand and navigation systems continue to improve, severe traffic jams still occur during rush hours, accidents, rainy weather, and emergency situations. While thinking about this problem, I focused on traffic signals. Many intersections still use fixed traffic signal cycles. One direction may have dozens of waiting vehicles, while another direction has very little traffic. Yet uh, both directions receive the same amount of green light time. This approach is inefficient. Busy directions often do not receive enough green light time, while empty directions waste valuable signal time. Therefore, I came up with the idea of dynamically adjusting signal timing based on real-time traffic demands. Based on this idea, I developed Smart Signal. The goal of this project is not simply to create another traffic simulator. The main objective is to demonstrate how an ICT-based system can collect traffic information, analyze traffic demand, make decisions automatically, and optimize traffic signal timing. In a real-world environment, cameras and sensors would detect vehicles and emergency vehicles automatically using AI. However, implementing a full object detection system was beyond the scope of this project. Therefore, I focused on building the adaptive signal optimization logic and simulation environment. Our intersection consists of four traffic directions: south to north, north to south, east to west, and west to east. The signal sequence is fixed: south to north, north to south, east to west, and west to east. However, the amount of green light time assigned to each direction is not fixed. Instead, it is recalculated every cycle according to traffic demand. This allows the system to adapt to changing traffic conditions while maintaining fairness among all directions. Now I will explain how Smart Signal calculates signal timing. In this project, I assume that one vehicle requires approximately 2 seconds to pass through the intersection. For example, 10 vehicles require 20 seconds, while 20 vehicles require 40 seconds. Therefore, the green light duration is calculated according to the number of waiting vehicles. Emergency vehicles receive higher priority. If an emergency vehicle exists in a direction, the system gives additional weight to that direction and allocates more signal time. Directions with no traffic receive 0 seconds to prevent unnecessary signal waste. To maintain fairness, a maximum signal time limit is also applied. The simulation follows several simple rules. First, only one direction moves at a time. Second, one vehicle requires 2 seconds to pass through the intersection. Third, if all vehicles cannot pass during the assigned green light period, the remaining vehicles stay in the queue. Those remaining vehicles are carried over into the next cycle. This creates a more realistic traffic simulation. Emergency vehicles are also processed before normal vehicles. This project follows a complete ICT pipeline. First, traffic information is generated through user input. Second, the data is transmitted into the system. Third, the system collects and organizes traffic information. Fourth, the optimization algorithm analyzes traffic demand and calculates signal timing. Fifth, the system assigns green light duration. Finally, the results are displayed through the dashboard and simulation. Now I would like to demonstrate smart signal using a custom traffic scenario. would like to demonstrate smart signal using a custom traffic scenario. For cycle 1, I set 5 vehicles from south to north, 25 vehicles from north to south, 20 vehicles from east to west, and 30 vehicles from west to east. I also added 2 emergency vehicles in the east to west direction. For cycle 2, I added new incoming traffic including 25 additional vehicles in the north to south direction. This allows us to see how a smart signal reacts when traffic conditions change. Now let's run the simulation. As you can see, Smart Signal first calculates the signal timing for cycle 1. After new traffic arrives, the system automatically recalculates the timing for cycle 2. The signal allocation changes according to the updated traffic demand. This demonstrates the adaptive nature of Smart Signal. Now let us look at the results. We compare Smart Signal with the traditional fixed-time traffic signal system. A fixed signal assigns equal green light time to every direction regardless of traffic demand. In contrast, Smart Signal allocates signal time according to actual traffic volume. To compare performance, we use a metric called the waiting score. A lower waiting score indicates better traffic efficiency. As shown here, Smart Signal reduces waiting time compared to a traditional fixed-time signal system. Currently, traffic information is entered manually. In future work, cameras and AI-based object detection can automatically collect traffic information, and real-world traffic datasets can also be integrated to improve prediction accuracy. In addition, multiple intersections could be connected to create a larger smart city traffic management system. In conclusion, Smart Signal is an adaptive traffic signal optimization system that dynamically adjusts signal timing according to traffic demand. It considers vehicle volume, emergency vehicle priority, and newly arriving traffic. Through simulation, we demonstrated how adaptive signal control can reduce waiting time and improve traffic flow. Although this project is currently a prototype, it demonstrates the potential of intelligent traffic management systems for future smart cities. Thank you for listening.